Back in Germany in the early 1800s, Mr. George Ohm figured out that current, voltage, and resistance are like a big happy family that all depend on each other. From this, the current divider rule was born. This rule states that the portion of current flowing through a single branch in a parallel circuit is related to how much resistance is in that branch, making the current's journey a little difficult. Realistically, this makes sense. The current in a circuit is going to choose the path with the least resistance, no matter the voltage behind it. The theory behind this is just as simple. Mr. Ohm found that the current is equal to the voltage divided by the resistance. Then, Mr. Kirchhoff came along and found that the voltages along the parallel branches of a circuit are all equal, meaning voltage can be taken out of the equation in the instance of the current divider rule. So finally, we find that as the resistance in a branch increases, the current allowed to flow through that branch decreases. Say you're shown this circuit, and you're told to calculate how much current is flowing through this top branch. Well, all you have to do is multiply the ratio of the total resistance over the resistance in your branch by the total current, or source current. We know here that the source current is 50 milliamps, and these branches have 10 and 20 ohms of resistance each. We can find the total resistance to be 10 times 20 all over 10 plus 20, which gives approximately 6.67 ohms. So now, plugging into the formula, or just looking at it realistically, we know that the current through this branch will be 50 milliamps, remembering your milli conversion, multiplied by 6.67 ohms over 10 ohms. And voila, we get 33.4 milliamps. We'll finish with a bit of a harder example. You're given this parallel circuit with a voltage source of 50 volts and resistances of 5, 10, and 15 ohms each. You have to find the current through the first branch. First, we find the total resistance to be the reciprocal of 1 over 5 plus 1 over 10 plus 1 over 15, which gives approximately 2.73 ohms. Then, using Ohm's law, we can find the source current to be the source voltage divided by the total resistance, which gives approximately 18.3 amps. Finally, use the current divider rule to find the first branch current, which gives 18.3 amps times 2.73 ohms over 5 ohms. And this equals 9.99 amps, all done. The trickiest thing in the current divider rule probably comes down to calculating the total resistance, but get some practice in and you're all set.